Hey, geometry students, in this lesson, we are going to be graphing and solving linear systems. This is a review lesson from what you learned in algebra, okay? And we learned that there are three ways to solve systems of equations. One way is by substitution. We're going to try that one out today. One way is by elimination. We're going to try that one out today. That's my personal favorite way. Some people love it, some people hate it. I'm going to tell you this: you never have to use either substitution or elimination. You could always choose which one. So you could always use elimination if that's the method you really like. Although sometimes it's way more convenient to use substitution. You could always use substitution and never elimination, although sometimes it's way more convenient to use elimination. So just so you know. And then lastly, we could just graph equations and find out where they intersect. And that would be the solution to the system of equations too. We're going to do one of those today, and we're just going to use GeoGebra for that. Now, you can't just do that for any system of equations. You should solve them algebraically when asked to solve algebraically. But when asked to do it by graphing, you can definitely do it by graphing. All right, let's get started on this one. First of all, we need to solve this system of equations algebraically, and we are going to do this the smartest way that we can. And I noticed that this one's equal to y, this one's equal to y, so why not just set them equal to each other? Because they both equal y, that means they're equal to the same value. So let's just set them equal to each other. I'm going to do that by writing out letter A as 2/3 x minus 8 equals, let's see, 2/3 x minus 8 is y. Well, this expression is also y. So these expressions must be equal. It equals 1/4 x plus 2. Now, the first thing I'm going to do to solve this is get rid of my fractions by multiplying everything by the least common multiple of the denominators of my fractions. So 3 and 4 have a least common multiple of 12. I'm just going to multiply this entire equation by 12. 2/3 times 12 is 24/3, which is 8x. Okay, now I have to multiply everything by 12. Minus 8 times 12 is 96. Equals, let's see, 1/4 times 12 is 12/4, which is 3x, plus 2 times 12 is 24. All right, and this is a very solvable equation at this point. So I'm going to subtract 3x from both sides. That gives me 5x equals, I'm going to add 96 to both sides. That's going to give me 120. 5x equals 120, or x equals, let's see, and it's going to be 24. X equals 24. Now, if x equals 24, I need to figure out what y is. I can't just figure out x. So I'm going to plug in x to one of my equations. Looks like the second one's going to be the easiest. So it's going to be 1/4 times x. Well, I know x is 24, so 1/4 times 24 is 6, plus 2 is 8. Y equals 8. Now, we solved this one by substitution when we plugged in the values. I'm sorry, we set the equations equal to one another. So basically I said, okay, so y equals 2/3 x minus 8. Hey, y also equals 1/4 x plus 2. I'm going to substitute this y with 2x, 2/3 x minus 8, because this equals y. That's substitution. Let's just make sure we got that one right. And it looks good. I'm going to tell you, most of the time in the problem sets, in these types of problems, the answers are going to come out as fractions, and you actually have to write the improper fraction as your answer. They won't usually come out as whole numbers like this. Let's see if B does. Okay, so solve this algebraically. This time, I'm going to see if I can use elimination to solve. To use elimination, I have to get y and x on the same side. So this is going to be y plus 2/3 x equals -3. Notice I just added 2/3 x to both sides of this first equation. My next equation is going to be y minus 1/2 x. I subtracted 1/2 x from both sides, equals 2. Okay, and then let's just look at these two equations compared to each other. I notice that This first one has a y, the second one has a y, and it'd be really easy if I just subtracted the second equation from the first equation to cancel out that y. So I put a minus sign here. I'm going to subtract these equations. I need to make sure I'm consistently subtracting each term from the second equation, of the second equation from the first one. So let's see. Y minus y is 0, so the y's go away. 2/3 x minus a negative 1/2 x. That's 2/3 x plus 1/2 x. Well, 1/2 is the same as, let's see. For this, I'm going to do some work over here. 2/3 x. I'm going to change it to 6. So that's 4/6 x. And then 1/2 x is 3/6 x. Does that make sense? So I'm going to give them a common denominator so I can combine them. So 4/6 plus 3/6 is 7/6x equals, and then negative 3 minus 2. I have to make sure I'm subtracting. Negative 3 minus 2 is negative 5. All right, this one doesn't look like it's going to come out to be a perfect number. It looks like I'm going to have a fraction, but let's see what happens. So now I have 7/6x equals 5. I'm going to multiply both sides of this equation by 6/7, right? Because 7/6 times 6/7 cancels out this term here. This just becomes x. So what this becomes is x equals, and then negative 5 times 6/7 is negative 30 over 7. Okay, that is what I got. That's good. Now I need to plug the x back in to get my y, and I know that that's not going to be a perfect whole number either. Y equals, I'm going to use this second equation because I think this is going to be the easiest. It's going to be 1 over 2 times negative 30 over 7. Okay, so this is just going to be multiplying two fractions. I'm just going to leave it in this form and note I'm going to multiply numerators, multiply denominators, plus 2. Okay, so this simplifies to negative 30, because 1 times negative 30, and then across the numerators is negative 30, over, then I multiply denominators, 14 plus 2. 30 over 14 can be simplified to 15 over 7. And then 2 is the same as 14 over 7. I just multiply 2 times 7 over 7 to get 14 over 7. And now I can actually add these. Negative 15 over 7 plus 14 over 7 is negative 1 over 7. So y should equal negative 1/7. Let's see if we got these right. They're such bizarre numbers, but that's what they are. All right, and then for letter C, we're going to use graphing, which I think we're going to find is a much easier way to solve these. For this one, we're going to go to GeoGebra, and we're going to plug in these equations, 3x plus 4, negative x plus 8. So here's how that's going to look. So we're going to open a GeoGebra calculator tab, and we're going to make sure that right for now we're in our algebra calculator. Okay, so start calculator. Just double check we're in the algebra one and not the geometry one. And then what we're going to do is over here on the left, this is the graphing calculator, so that's right. We're going to enter our equations. And what we're going to do is we're just going to type y equals, and then we need our linear functions, 3x plus 4, 3x plus 4, that's one of them. And then the other one is y equals, and let's see, it's going to be negative x plus 8, negative x plus 8. Okay, then we need to look for where our two lines cross each other. I'm going to click on that point to find the intersection. Sometimes it takes a few clicks, and there we go. 1, 7. So the solution for this one should be the point 1, 7. That is easy, but you also have to know how to solve these without resorting to using a graphing tool like that. So that's why we also need to know substitution and elimination. Hey, one other thing. What is 0.17? Well, that's the one point. Actually, all three of these are the one point that solves both equations. If you plug this point into both equations, it's a solution. And it's the only point that solves both equations. Let's look at letter D. Determine if there is a solution for this system. Back in algebra, we had a special name for parallel lines. We called them inconsistent because they do not cross one another at all. They never touch each other. And if there is no point where these two lines cross one another, there is no solution for the system. Because remember, the solution for a system of equations is the point where the two lines or the two graphs of the equation intersect. These two graphs will never intersect each other. Hey, what would happen if we just tried to solve this anyway using substitution? All right. So if I try to use substitution for letter D, look what happens. And I'm just going to note that this is letter D. And we're going to do, okay, so negative 2x minus 3 equals, because they're both equal to y, that means they're equal to each other, negative 2x plus 1. I'm going to add 2x to both sides to try to get x on a side by itself. What do I get? Negative 3 equals 1. My x term disappears, and I get a statement that is not true. Negative 3x is not equal to 1. Therefore, what I found is that these equations have no solution. All right, then finally on to letter E. In letter E, I know the supply curve for a product has that equation. The demand curve has the other equation where y is the price and x is the number of units sold. What is the optimum price of product and how many units will be sold at this price? Ooh, okay, so what I'm going to do for letter E is solve the system of equations. I'm going to choose substitution because when they both equal y, it's just so easy to use substitution. 2x plus 20 equals negative 1/2 x plus 80. Now I'm going to add 1/2 x to both sides. I get 2.5 x, or 5/2 x is the improper fraction way to write that, equals, I'm going to subtract 20 from both sides, equals 60. I'm going to multiply both sides of this equation by 2/5 to get rid of the 5/2. So I'm going to multiply this side by 2/5 as well. 60 times 2 is 120. 120 divided by 5 is 24. That means that x equals, I just noticed it actually put an F in here, x equals 24. And if x equals 24, I can go back to either of my original equations. I'm going to use the first one. 2 times 24 is 48, plus 20 is 68. Y must equal 68. Again, if x is the number of units sold, so it's going to be 24 units sold, and this is going to be the price of the product, $68. Let's see if we've solved this correctly, and it looks like we have. All right, and that is how you work these sorts of problems. You can do the problem set for next time.